Today we are going to discuss the derivation of area of triangle in coordinate geometry. So we know in coordinate geometry, apart from distance formula and section formula, this is another important formula in 10th class syllabus. So now let a x1 comma y1 b x2 comma y2 and c x3 comma y3 are the vertices of a triangle ABC. Then the area of triangle ABC is given by delta, which we used to mention for the area of triangle. Delta is equals to half of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. This usually we take it as a formula for the area of triangle. Now I am going to discuss the derivation of this particular formula, how we actually arrived this formula. So now let me erase everything. So before going to this particular derivation of the formula, let me tell you another important information which we are going to use here, that is area of trapezium. So trapezium means we know that one is a quadrilateral in which only one pair of opposite sides are parallel. So formula for trapezium is half into sum of parallel sides into height. This is the formula for area of trapezium. Usually when you take a trapezium, height means distance between parallels. So sometimes we may get a triangle, we may get a trapezium in which one angle is 90 degrees. Automatically another angle also, its adjacent angle also is going to be 90 degrees here. So I am showing both the figures here, whether the trapezium is this type trapezium or particularly right trapezium. So whatever it will be the trapezium, formula doesn't change, half into sum of parallel sides into height. So now, keep in our mind, so this is the main important thing what we are going to use in the derivation of area of triangle formula. So let me erase everything. So I am showing the formula here, area of triangle formula. So now how we are going to arrive this formula using the regular observations in the plane. Let me explain. So now let me erase everything. So now take x-axis and y-axis. Origin is there. Y-axis is there, x-axis is there, everything is there. So now let me take directly 3 points A x1 comma y1, B x2 comma y2 and C x3 comma y3 are the 3 points on the plane. So now on joining all the 3 points we are going to get a triangle. Now we are supposed to find out the area of this triangle in terms of x1 y1, x2 y2, x3 y3. So now as we have done two different derivations in coordinate geometry like section formula and distance formula, almost all every process will go on in similar way. So we used to drop the perpendiculars to both x-axis and y-axis. First of all here, let me drop the perpendiculars to the x-axis. What you are going to get? From A, I drop a perpendicular, so we got something D. From B also we drop a perpendicular, let me take it as E. And from C also, let me drop a perpendicular and let us take that point as F. So now clearly you can see D, E, F are the 3 points on x-axis. Now we need not to think on y-axis. Let me think about this one only. So what you are going to get, the length of OD is going to be x1, right? Why? Because the point is x1 comma y1. The length of OE is going to be x2, why? Because the point is x2 comma y2. The length of OF is going to be x3, why? Because the point is x3 comma y3. So now, is it possible to find out the distance between D and E as well as E and F? So D and E, how much it is going to be? As OE length is x2 and OD length is x1, the DE length is going to be x2 minus x1, right? Now similarly, if you observe carefully, the length of EF is going to be x3 minus x2. Is it clear? So we got DE length as x2 minus x1, EF length as x3 minus x2. So now, is it possible to find out the distance of DA or AD, which is nothing but y1 length? Why? Because the point is x1 comma y1. Similarly, DE length is going to be y2. Similarly, CF length is going to be y3. So now, I did not drop any perpendiculars to the y-axis. Why? Because this is more than enough to get the formula of area of triangle. So now, from this entire figure, how will you get area of ABC? I am not talking about the formula. from the figure, if you see so many different figures are there like triangles, quadrilaterals, but if you observe carefully, A, D, E, B, A, D, E, B, clearly you can see a trapezium. Similarly, B, E, F, C. B, E, F, C is also another trapezium. How can we say that they are trapeziums? Why? Because as we dropped perpendiculars from ABC to the x-axis, all the three perpendiculars are parallel to each other. Definitely these two figures, whatever I am showing, or quadrilaterals, whatever I am showing, they are the trapeziums. So you can see clearly two trapeziums. As I closed everything, so from this particular figure, how will you get the area of ABC from these two trapeziums? Again, if you subtract the trapezium ADFC, so you can see three different trapeziums clearly. One is ADEB and another one is BEFC. From these two trapeziums, if you subtract the area of trapezium ADFC, you are going to get ABC. So I think it's very clear how will you get the area of ABC from this particular part or figure. So now let me minimize this figure I'm showing here. So just I minimize, you can see there. So now clearly I'm writing area of ABC is equals to area of ADFB plus area of BEFC minus area of ADFC. So now what will be the formula for area of trapezium? As already mentioned, the area of trapezium is equals to half into sum of parallel sides into height. So now clearly I am showing that one. For first trapezium, what will be the parallel sides? AD and BE will be the parallel sides, and without giving explanation, I am leaving to you. DA is going to be height of this trapezium. How? So just you are supposed to rotate the diagram or rotate the trapezium. You can understand which are the parallel sides and which is the side, which is the height. So now you can see clearly half into AD plus BE into DE is nothing but area of trapezium ADEB, right? Now area of BEFC, what you are going to get, half into BE plus FC into EF is going to be the height of that particular trapezium, or EF is going to be the height of that particular trapezium. So now minus, so we added these two trapeziums and minus the final trapezium. What is the trapezium? ADFC I showed. So half into AD plus FC into DF is going to be the height of that trapezium. What is the DF here? I did not mention anywhere in the diagram. DF is going to be x3 minus x1, right? So now, if you see carefully this entire formula, in every part half is there. So let me take half as a common factor. So taking half is equals to. So now substituting the values for all the sides whatever I mentioned. So what you are going to get half into in the bracket. So look at this one. Y1 plus Y2 of x2 minus x1, right? Y1 and Y2 are the parallel sides of first trapezium. x2 minus x1 is the height of first trapezium. Plus Y2 plus Y3 of x3 minus x2. Y2 plus Y3 are the parallel sides. x3 minus x2 is the height of that trapezium. Minus y1 plus y3 of x3 minus x1. x3 minus x1 is the height of final trapezium. y1 and y3 are the parallel sides. Now observe carefully, in every part we got parallel sides as well as the height, and if you simplify and if you arrange in proper order, the thing what you are going to get is nothing but the area of triangle, that is half into x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. So that's what we are going to get here. So my dear children, this is how we used to get the formula on derivation. So using this formula, we have many different problems are there, but this is how the formula actually has been arrived. So hope you understood this particular derivation of the formula. We'll meet in the next video with another topic. Until then, take care. Bye bye. Yours, Lekala Master. Today we are going to discuss the derivation of section